Hi, today we're going to take a look at properties of an isosceles trapezoid and using coordinate geometry to figure out if the figure that we have here is an isosceles trapezoid. So what is an isosceles trapezoid? An isosceles trapezoid is a four-sided figure, a quadrilateral, that has one set of parallel lines. Now, in order for it to be isosceles, our legs have to be the same. So what we're going to do over here is figure out, do we have parallel lines here? How do we find that? We're going to have to look at the slope of all of these and say, do we have slopes that go in the same direction? Next, if this leg and this leg are congruent to each other, that means they have to be the same distance. So we're going to bring in the distance formula for that one. You could either look at the distance of our legs or look at the distance of our two diagonals where they both have to be the same. So we're going to take a look at look for slopes and then use a distance for our two legs. So that's where we're going with that. So we've got our picture over here. We could just do a simple rise over run to figure out what our slope is. And with our top one over here, if I rise and I run over, I'm going to be left with a slope of 1 over 5. Off to the side over here, I'm going to go down and to the right, giving us a slope of negative 2 over 1. On the bottom, we're going to go down and backwards, so we have negative 3 over negative 4. And lastly, over here, we can go up and back, which gives us negative 4 over 2. Okay, well, do we have the same slope? I don't see any of these fractions that are the same. Here's negative, negative, that's positive, but hold on, wait. Two negatives make a positive. So these two opposite of each other, 3/4 and 1/5, not the same as each other. So these could be possible legs. These two, negative 2 over 1, negative 4 over 2, this one can be simplified to 2 over 1. So here are your parallel lines. Because we have parallel lines, we in fact have a trapezoid. We need to figure out, what about the legs? Are they the same distance? So we're going to say, bring in our distance formula. Distance equals the square root of, we're going to take our x's, x1 minus x2, square it, and our y's, y1 minus y2, square it. Let's plug some numbers in. Let's just look at our legs. I'm looking at C and D right here. So my x's, I have 3 minus negative 1. 3 minus negative 1, square it. That gives us a plus in the middle. 3 plus 1 is 4. 4 squared is going to give us 16. And our y's, 3 minus 0. Square that, 3 minus 0 is 3. 3 squared is going to give us 9. So this gives us a square root of 25. So I could go further with that. I could say, that equals 5. But this is good enough if it's not a perfect square. Let's take a look at our other diagonal up here. We're going from A to B. So we have our distance formula. And that's going to give us, so x minus x. We'll say 2 minus negative 3. 2 minus negative 3 squared plus, let's do our y's, 5 minus 4, and then square it, leaving us with, we got plus signs in there, 2 plus 3 is 5, 5 squared is 25, 5 minus 4 is 1, 1 squared is 1, leaving us with square root of 26. Now, I don't really care what the decimal is of this, or if a simplified radical version, I don't care. I know I have radical 26, I have radical 25. They are not the same number. So this side and that side, those two legs, they are not the same. Do we have an isosceles trapezoid? Unfortunately, we did all this work to find no, we do not. These would have to be the same. And that's using properties of isosceles trapezoid and coordinate geometry.